This is lecture 1 of course soft computing. In this lecture, I would like to give an introduction to soft computing. Now consider a problem. That is, in your class there are 60 students. Out of the 60 students, you have to identify set of students who are tall enough, right? And do you think that there is a mathematical formula where you will be able to identify the set of students who are tall? No, right? So, but using your own intelligence, using your own intuitions, you can extract a set of students who are tall enough. Your intuition is like people with 6 feet or more will be tall, and even you can consider people with 5 feet 6 inches, above 5 feet 6 inches can also be considered as a set of people who are tall. And set of people who have height less than 5 feet 6 inches or in and around 5 feet can be considered as short, right? So you are using your own intuition, your own intelligence for extracting such kind of solutions to the problem which we had. So actually we don't have a mathematical, we cannot bring about a mathematical equation or an expression for for solving such kind of problems. So thus another example is weight of the people, right? So these are set of problems, real life problems where you don't have a particular mathematical formula for the problem. So for such kind of problems, scientists called LAZ has introduced a solution, a technique called soft computing, which differs from conventional hard computing in that, unlike hard computing, it is tolerant of imprecision, uncertainty, partial truth, and approximation. In effect, the role model for soft computing is the human mind. So, human mind can be considered as an analogous to the soft computing. Definition. It was actually Said has introduced this particular solution in the way back in 1960s. This is a solution which from the book he has written in 1992. The definition is stated as soft computing is an emerging approach to computing which parallel the remarkable ability of the human mind to reason and learn in an environment of uncertainty and imprecision. Now let's look at the goals of soft computing. Soft computing is a new multidisciplinary field to construct new generation of artificial intelligence known as computational intelligence. So we'll be having new set of algorithms which will be able to solve the real life problems where we don't have a solution. The main goal of soft computing is to develop intelligent machines to provide solutions to real world problems which are not model or too difficult to model mathematically. Its aim is to exploit the tolerance for approximation, uncertainty, imprecision, and partial truth in order to achieve close resemblance with human-like decision making. Let's look what is approximation. Approximation, here the model features are similar to the real ones but not the same. Uncertainty, here we are not sure about that the features of the model are the same as that of the belief we have, right, or as that of the entity. Imprecision, here the model features are not same as that of the real one but close to them. You are bringing a close solution to your uncertain problems, right? There are several algorithms for in this area, that is example algorithms or tools, or it can be called as tools, techniques, whatever it is, right? The examples algorithms are fuzzy logic, artificial neural networks, evolutionary computation, swarm intelligence, that is ant colony optimization, and particle swarm optimization. Additionally, some machine learning algorithms and probabilistic reasoning areas are there. Example, probabilistic reasoning area is naive-Bayes classification algorithm, etc. Right. Now let's look what is the unique property of soft computing. That is, we are learning from experimental data. That is, you have some problem, you have some set of data. We have already discussed this particular learning strategy in machine learning that we had discussed in the previous semester. Machine learning course we had discussed, we have learned in the previous semester. There also we are learning from the experimental data. If we have an entire data set where we'll be having an input and output, and from that we are learning models out of that. That is, we are generalizing to a particular solution. Soft computing techniques derive their power of generalization from approximation or interpolating to produce outputs from previously unseen inputs by using outputs from previous learned inputs. Generalization is usually done in a high dimensional space. Now let's look what is hard computing. Hard computing, that is conventional computing, requires a precisely stated analytical model and often a lot of computation time. Now, simplest of the example is that you have learned in your schooling, that is, you have a mathematical expression for calculating the interest of a particular loan which we have done, right? And there are mathematical expressions which relate the profit and loss for the expense for the business we make, right? So these are called hard computing. There are specific models for such kind of problems. Many analytical models are valid for ideal cases. Real world problems exist in a known ideal environment. So many problems in the real world are known ideal. You don't have a specific solution or a unique solution to a real life problems. And the guiding principles of hard computing is that these problems are precise, certain, and rigor, right? Many contemporary problems do not lend themselves to precise solutions. That is, real life problems like recognition problems, handwriting, speech, objects, images, text, all these recognition problems does not have a unique solution or a precise solution. And another set of solution problems, real life problems like mobile robot coordination, forecasting, weather forecasting, combinatorial problems, etc. Reasoning on natural languages. These are set of real life problems where you don't have a unique solution, where the solution is imprecise, where you are bringing some kind of accuracy with compromising some set of errors to that. Current applications using soft computing include handwriting recognition, automating systems and manufacturing, image processing and data compression, architecture, decision support system, data mining, power systems, control systems, etc. Future of soft computing. The idea of soft computing was initiated in 1981 when Lofty A. Said published his first paper on soft data analysis. What is soft computing? That was published in the journal called Springer Verlag. Right. Sage defines soft computing into one multidisciplinary system as a fusion of fields of fuzzy logic, neurocomputing, evolutionary and genetic computing, and probabilistic computing. So there existed many kind of computational techniques way back in 1940s. Artificial neural networks, etc., was introduced in 1940, etc. Right. So what Said has done is that he has brought together all these fields into one terminology called soft computing. So this is a pictorial collection of soft computing algorithms. It is a combination of artificial neural networks. Artificial neural networks is learning and adaptation, which we have seen in the previous course. Fuzzy set theory is knowledge representation via using if then rules. Genetic algorithms, it is a systematic random search technique. So you can conclude like soft computing is a combination of evolutionary computing that was introduced in 1960. Neural network, the first neural network algorithm was introduced in 1943, and fuzzy logic was introduced in 1965 by Zaid itself. So what Zaid has done is that he has combined all these three technologies together under one domain called soft computing in the year 1981. So evolutionary computing also includes algorithms like genetic programming. It was introduced in 1992, and evolution strategies were in 1965, evolutionary programming in 1962, and genetic algorithms in 1970. The soft computing consists of several computing paradigms, mainly fuzzy system, neural networks, and genetic algorithm. Fuzzy set is for knowledge representation via fuzzy if-then rules, neural networks for learning and adaptation, genetic algorithms for evolutionary computation. So these are the main three areas introduced. Available in soft computing. Even you can have algorithms where you can have hybridization of these algorithms. You can have neurofuzzy hybrid systems, neurogenetic hybrid system, fuzzy genetic algorithms, etc. All this hybridization of algorithms with hybridization concept is available. So hybridization of these three creates a successful synergic effect, that is hybridization creates a situation where different entities cooperate advantageously for final outcome. Thank you.